Scott's Geography Notebook.
Da, da, da.
Latent heat can be defined as the energy related to the phase change of water. Okay, now we have water in three different phases. We have it as a solid, we have it as a liquid, we have it as a gas. So let's take a look at some of these different forms of water, and then the process of changing. So the first one that I want to do is going to be ice. Now, ice, we know that ice is a solid. And then let's go ahead and add in a few other ones. The next one I want to add in, I'm actually going to do 2 for water, because I want to do liquid water, except this one I want to do at 0 degrees Celsius. And then I want to add one other one here. Good. One other one here. And this is going to be water again, except this time it's gotten hot. It's at 100 degrees Celsius. Okay, and then I need to draw water vapor, but water vapor is invisible, so I'm just going to use like the really fine tip one. Okay, and we'll label that with water vapor. Or as a gas, right? So we have gas, we have liquid, and we have a solid right up here, right? Now, what do we need to do in order to get ice to go to water? We have to add energy. Okay? How much energy do we need to add? Well, here's what we want to do. In a previous discussion, we learned that 1 calorie is going to change 1 milliliter. Now, 1 milliliter is the same as 1 cubic centimeter, 1 cc, or 1 centimeter cubed, right? So if we could picture this as 1 centimeter by 1 centimeter by 1 centimeter, that's kind of small, right? So, good. 1 centimeter by 1 centimeter by 1 centimeter. If we could picture that tiny little ice cube that's there, how much energy do we need to get it to go to its liquid phase? Okay, so in order to have it change, and this is also going to be at 0 degrees Celsius, right? In order for it to just change phase from a solid to a liquid, we need to add 80 calories of energy, right? And that's going to be changing it from the solid to a liquid. If we want ice to melt, we have to add energy. How much energy? 80 calories will be absorbed. Now, this doesn't change the temperature. It's 0 to 0. And that's why it's called latent heat. Okay? The latent means it's maybe not changing temperature, it's just changing phase. Okay? Cool. All right, well, let's just keep going. Now, if we are sticking with our 1 centimeter by 1 centimeter by 1 centimeter of water, our cubic centimeter, then what we're going to be doing is we're going to be adding energy to get it to go from 0 to 100, and that is adding 100 calories. Those will be absorbed. Now, this little phase, or this little change that we have going from water, we don't want the arrow going that way, just going that way. Good. Going from water 0 to 100, it's not latent heat, it's called sensible. Okay. And that means like you can sense it, you can feel it. Okay, now what's the last step that we need to do? This one is the biggie, right? In order to change phase from water to water vapor, let's think a little bit about this. These little water molecules, they're really friendly with each other. Okay, they like to stick with each other. It has to do with the hydrogen bonds. They don't want to let go. And so we bring the water all the way up to 100 degrees Celsius by adding another, right? This is ice water, basically, and bringing it all up almost to boiling point, right? That's going to be 100 degrees Celsius. That is our boiling point. But in order for each individual water molecule to be free to escape, in order to get at least a cubic centimeter of that, we need to add another 540 calories are absorbed. Okay, so in order to take your entire pot of water and make it go to a water vapor to boil it all away, that is a lot of boiling. Right? This over here is also going to be our latent heat because it is associated with a phase change of water. So solid to liquid is 80 calories. Once you bring the liquid up to the right temperature, then it's another 504. That's crazy! Think about the energy that it takes to take nearly ice water up to nearly boiling water. Like this will scald your hand, right? All the way up to make it, that's 5.5 times, or 5.4, almost 5.5 times the energy that's associated there. Okay, now, what happens going the other direction? Well, it's the same numbers except in reversed, right? In order to go from water vapor to water as a liquid, this process, it's going to be 540 calories released. Okay, now, what happens, right? One place where this happens is in the formation of a cloud. So when we have a cloud forming, a cloud is actually going to be water droplets, liquid. Water droplets. Right? So we actually have those droplets floating around. When the water vapor turned into water droplets, that energy was released. And we're going to talk a lot more about this cloud formation and the amount of energy that is associated with that process of going from a vapor to a liquid. Okay, so if you wanted to make your water get colder, you'd put it in the refrigerator. And in that process, it would be removing another 100 calories from that water. Your refrigerator absorbs energy. Your freezer also absorbs energy because if you take that water now and you put it into the freezer, it's going to be absorbing, right? So it's this process is releasing the energy, right? So the water is sending it out, and so the environment has to take it up, right? So this is going to be releasing another 80 calories, and this is going to be latent heat. Right, now, let's just think really quickly about this. We've got all of our numbers figured out, but I want to think a little bit about this visually. If we can picture the water, if the water is absorbing that energy, okay, what we basically have is we have our water, and then we have the environment all around. Environment all around, right? Okay, so if that process is going to be absorbing heat energy, okay, that means that the energy is coming from the environment and going to the water. Okay? What will happen is we'll have positive energy going to the water, and that energy is coming from the environment. Okay? So if we have ice going to water, if I hold an ice cube in my hand, it's going to make my hand really, really cold. Why is that? Because it's going through a phase change of water. It's absorbing heat energy and it's pulling that energy out of my hand. Right? The process is the same in reverse, right? So we talked about the cloud formation, and we talked about our freezer, right? But what's going to be happening is if that energy is being released, it's coming out. That means that the environment is going to be getting warmer, and our water, right, starts to release that energy. Right? It doesn't that they get colder, but that energy is going to be going into the environment. If you reach to the back of your refrigerator or your freezer, it's going to be really warm back there. That's where it releases that heat energy. Right? So in all of these different phases, if the water is absorbing that energy, it's going to be cooling the environment. Right? And if the water is releasing energy, then that's going to be making the environment a little bit warmer.